Everyone stay nice and quiet.
He's trying to record something. I'm not sure what.
A sound. Okay, we're good.
Okay.
Where were we?
You wanted to
We had
start going
topics.
through state charts.
We had topics. We did. There was making the state chart for the protocol.
Which is done already, right? It's just you wanted to make it more functional.
It's not. I use the state chart to simply imperatively describe the program flow, which was certainly a step up from just doing
writing code.
Yeah, right. So it's a big step up there, but it's still. I'm unhappy that it is not declarative. Like it doesn't. The spec for how the protocol should work is not. It's not declared. It's not. It's implied from like do this thing, then move this thing, then check this thing. I want it the other way around. I want the spec of the state chart to be driving the behavior of the code beneath it.
Mm-hmm.
I have fucked up, but I do not know how to correct it.
Yeah, it's a tough one, right? Like imperative is like an escape hatch, basically. Like when you're building something, it's usually easier to just like juice a bunch of stuff, no matter whether you're using a state machine or just a normal code file, which is arguably a state machine in and of itself. I've been reading protocol documentation a little bit recently, just trying to wrap my head around how to describe a protocol properly. And like it is very much like talking about, this set of bits goes in this part of the message, this set of bits goes in this part of the state kind of thing.
Yeah, I mean,
so
like the models layer. So there's 3 layers of the system. There's the models layer, which is the static, queryable, immutable state of the system.
Yeah.
Then there's the producers, which are functions that take a collection of states and produce another state. And then there's the state machines, which coordinate the order and the orchestration between the outputs of one producer and the inputs of another, so that you run the whole thing as a system. Now, I'm happy with the models because I know that they would make they're very close to protocol definitions, because it's like this message has this format and only this format. That's great. The producers, I'm reasonably happy with them because they are pure functions with no dependencies that just transform state from one to the other. The order in which they get called is the problem.
Yeah. So that's in standard engine, right?
Standard engine, that's right.
And it's the machine definition, which is the index, no?
The machine definitions are all of the everything in machines.
Right.
Is the actual X state format state machines. And you could, because a state chart, machines can be composed into higher state charts. You can basically combine all those and say that this is the one single state chart that describes the entire engine. So, it's got some good aspects in that sense, but they're all still, they don't specify what they're doing, they just do it.
Yeah. Okay. So that all tracks with me. Like what I see is basically each one of these state machines like appears to be monkeying around with multiple different models inside of it. Right.
You are correct. However, there is an element of isolation there to some degree. Like, for example, the increaser only deals in blocks and interblocks. The isolator deals in a DMZ, which is the internals of a block, plus the plus actions, and then the interpreter deals with a single action, a single DMZ, and exhausting the loopback actions.
Mm-hmm.
So there is a strategy or an isolation scope. There's like telescoping down from like big, here's a block, and then
Right. So what I'm trying to get at here is, if I understand the description you've made here, basically, but like the models are like schemas, basically, right? So they're describing what possible shape the state can have and what possible types that like data can have in cells in the state.
Correct.
The producers are basically the functions that the machines pick up in order to actually do the work, right?
Correct.
What you just said is like this machine like involves the following 3 or 4 models, right? Yep. It like even just a starting point for you there would be like, can we list on each one of these what are the models that are involved? Because
it's listed already. Like, it's listed already. In
context?
Yeah, context describes. Okay, so one of them has a to do in there, but for the majority of them, the context describes the models that are operated on by that particular machine.
Right. So what I would imagine is that it's not possible. Like there is always a switchover, like between this is the thing I'm dealing with and this is how I'm dealing with it. Right. Like you can't avoid the task of describing how you want the machine to work. It has to happen at some level.
Yeah, I know, but I want to split it. I know that so the config files sort of describe. If you look at the config files, I tried to make those functions very linear. So there should be, in each function that gets called, there should be no ifs, so no branching, no looping, no internal conditionals. They're really just straight up linear functions that do a single purpose. Those are the places where I would expect the how to occur. It's just that the orchestration in the state chart also appears to me when I read it, it reads like how, not what. And you could not, for the life of you, just read the state machine definitions and determine what the protocol was doing. Like you just... I mean, I have trouble determining it, even though I can read all the files, and I made them. But
can I just raise a point that's kind of why I was so harping on the requirements document in the first place? Because the definitions aren't really
right.
requirements.
No, I understand the drive for a requirements document, but our lessons over the past 7 years have shown that the requirements docs are too heavy. They don't help us with the fact that we are still in prototype mode. And what I'm really hoping for is that the specification can be made in terms of state chart, because that you can then take that and explode it out to a long form written specification. But most importantly, it stays as the running heart of the machine. It doesn't, the map is also the territory, as Ben likes to say.
I suspect strongly that if we were to decompose each one of these state machines into a folder where it's simply managing a bunch of sub-state machines that are particular to one model, one piece of the state, that the descriptive kind of nature would fall out of it.
It does already do that, except I've flatten the folder structure. So if you take a look at interpreter.js and then look down at look at line 79 downwards, you see how there's the action of assign direct machine that gets called multiple times. That is calling submachines that only ever get called in that state of the state chart. So it's already decomposed like that, but then I just flattened the machines because
folders are annoying.
Well, yeah. But so is an imperative machine.
It's not as imperative as you think. Like, even just running through it, just having you describe or answer my questions here. What it could possibly be is that maybe the names, like the action name assign direct machine, going to a different state chart inside this state chart.
Like the way that I broke up or nested the machines might be hiding. Yeah.
Well, that's going to be what it is, right? Like, that's at some point you need to flip over from in my experience, the higher you build the models up into the program,
right,
the more descriptive your function names end up being.
Yes.
If you take my meaning, basically, like it's.
I take your meaning. That's not the error that I'm seeing. The error that I'm seeing is that I can't model the options available for where the machine can go next in terms of a protocol for describing the rules by which the state of the block may transition during block making phase. Those rules are not captured.
They're not captured, or they're captured too low down?
They are not captured explicitly.
Okay.
So like, because when I debug this system, I basically run a series of different chain exercises, and I look at the output of the blocks, and I work backwards to see when the output of the block was erroneous, or when it sort of made it through the filters so that a block that shouldn't be allowed was allowed. And so I sort of like plug the holes in the machine so that only an allowed format block can come out. But I'm not really saying what the allowed format was during each stage. So there's it's like a sub schema of what could.
There is guard functions for the state machines, right?
Absolutely, yeah.
So what you're saying is you came up with a bunch of guard rules that are just in your head right now that need to be turned into actual literal guard rules.
No. There's I've got them out of my head as best I can. They are very explicit. Each one logs. They all carry assertions defensively, as though neither one could rely on any of the others. It's that I believe that to describe the specification of the protocol, it is insufficient to simply describe its wire format. There is a logical description of how you can modify the block during its malleable block formation phase. There's only certain things you can do given the current state of the block, and there's only certain ways it'll ever move based on what you're going to do next. And I want those. Sorry.
No, I'm sorry. That's what state machines are for, right?
It's almost like I am asking for a second state machine that is the protocol description state machine that these state machines fulfill or use as their checker or their guidance.
Right.
Like I want to almost split the machines in two. So there's one machine that is the protocol specification, and then at each state in the protocol specification state chart, the how to do it machines are operating, they do their work, and then they come back to check if their proposed transition was allowed.
Is this part of the validator chain?
No, this is even narrower. This will be used by the validators, but this is.
Well, I mean, are you saying that you want a validation side chain, like that kind of runs parallel to the state machine?
No.
Okay, right.
Hang on. I think I'm asking for a parallel state machine that is not a chain itself. It is just a executing state machine that can only be moved in ways that the block formation protocol describes, because it is the protocol description. And then during block formation, the state machines that I have constructed right now are operating to move between the allowed state transitions of the protocol state chart.
I mean, it sounds like a stale validation, like checker, almost like a sanity checker, to make sure things didn't collide, right?
Yeah, I guess it is. It's a top level thing, but I want it to be more than just a checker. I want it to be the protocol specification, so that you can read it and you can then transform that into whatever specification format you may like. Now, crucially, having it in state chart form means that we stand a chance of formally validating it using something like PyCalculus or some other more computationally intensive tools.
I want to back up just a second here, because, correct me if I'm wrong, it sounds like you're saying you want to allow people to transform the state, and then you want to disallow the resulting state if it doesn't pass the correct conditions.
Correct.
So, like, wouldn't it be simpler to just not allow the system to ever go into an incorrect state? Like, I don't think there's two state machines here. I think there's one, basically.
If you don't have two, then you have to do the work using non-state machine operations, some of which may be complex. I think there's a mismatch in the level of detail required to perform the action versus the level of detail required to guard the action or describe the allowed result of a particular transition. How to get there can be complex in some cases, I think.
Right. So, I mean, are we mostly talking about the interpreter chain now that's running foreign code?
That would be the yes, but only because the interpreter chain is the interpreter machine, is the most heavily repeated or used one, because it gets called on every single, not just every single action that gets processed, but every single loopback action that gets processed as well. So it gets called the most. Right. It's not the busiest because of any other reason.
Yeah, so this, like, what's motivating what I'm asking here is just the old functional programmer saw of make illegal states here unrepresentable. Like, a sufficiently well-constructed, like, state producing machine should already describe the possible states.
But it won't do it in a state chart that can be manually translated into other consumable protocol specification formats, right? That's the problem. You can hide it. You can do exactly what you say, and yet the protocol may still be undecipherable from all but the most intimate of workers working on the system, right? And I want to get away from that.
Yeah, I understand the goal. This is just I'm trying to map out the edges of your request here a little bit. Like, what is it about producing a new state? Like,
I think we're talking about the minimum requirements, right? Is that what we're saying? What are the minimum requirements for state change?
Not just the minimum, but we're talking about all of the requirements for a state change. But I want to talk about it insofar as I don't give two stuffs how you get there. It's just that you can only transition in these ways.
Here, let's try a new approach here completely. Give me an example of a guard that you want to implement. Like, give me an example of one like check for, is this an allowed state?
An externally received action has completed processing and the loopback channel still has unprocessed actions on it. That's illegal.
Oh, okay.
And so you see, that's a good type of question to ask, because you end up with, I can answer you any questions like that, but to point at the code, I have to point through multiple machines to say how that constraint is enforced. It's not enforced independently of how it's done.
Yeah.
And so when someone like Troy comes along and says, what are the requirements of the system? I'm like, I can answer any question, but I can't do it. I haven't done it already, if you get what I mean.
So actually, I understand why you need two now, right? Because like what you're saying is there are places throughout the engine here, where you don't know how things are going to work, beforehand, basically. Yeah, and you never will, because this is a system that's running foreign code. So you need to know what states are allowed.
I want to block that avenue immediately. The system is running foreign code. However, that is unrelated to what the protocol specification is, because the running of foreign code is reduced right down to current state, next action, give me back the next state, plus the external actions you wish to transmit. And that, the state machine needs to allow any combination of those input parameters and output parameters. Mm-hmm. But in this higher level state machine, I also want to be able to introduce constraints such as no single run of the machine can issue more than 1,000 foreign actions in a cycle, for example. Right? Like, I want to be able to put some reasonable constraints on and have those at the top of the specification as opposed to buried deep in the internals. I don't want to write down those constraints in a document that becomes decoupled from the actual machine, because that will drift for sure, and then it's a huge amount of labor to sync them up each time. In the meantime, who knows what that document's being used for in its stale prototypical state.
No, I get you 100%. So, there will always be two sides to this equation. There will always be the produce and then the validate.
Right. That's what he's asking for, is something that is running alongside that's validating blocks, right?
No. Sorry, not validating blocks, validating the multitude of intermediate steps that go in between a block and the next block that comes after.
Okay, so intermediate collisions, is that what we're referring to then?
Intermediate, I want to describe the series of valid intermediate states that are permitted from block to block.
Okay.
Always between the blocks.
Yeah,
right?
Between the blocks, because I've very concretely described what the limits and the format and the logical relationship between all the items within a block are and how they relate to the previous block. That is trivial to specify relative to specifying how you may reach the next block.
So I think that this does not live inside of the code that's running in the lift here, basically, right? Okay. So like in the interpreter. I think this lives at the tail end of the block production.
No. I think you're right in that it doesn't exist inside the machines. I think it exists above, and it defines what step means. This machine defines what step is, and it starts with a certain thing, arbitrary code runs, and then the next intermediate state comes back and is verified.
Right.
So I think it's
so I want to... Intermediate step for you here means, and I'm really sorry I'm cutting you off all over the place. No problem. Intermediate step here for you means the thing that will become the next block, or does it mean inside of the block?
So what's the difference between those two things?
There's a big difference.
I know you're still inside the block, but what I'm saying is there's a place in the block production where I'm done modifying the state,
right,
and I have not yet signed and sent the block across the network.
Okay, I do not need any help specifying that. That is already done and is easy to do, because I can look at any given proposed block and I can either validate it or invalidate it based on the format rules plus the logic checks that go in it. And what's more, I can verify that this is the next block in the chain given the previous block. Those are easy to do with JSON schema.
Okay.
Plus some logic checks that say how those schemas, how the permitted parameters within the schema may be configured so that they don't conflict or say anything that's considered insane within the block.
Can I use maybe an Ethereum analogy here?
Yeah.
Because from what it sounds like we want a mempool requirement.
No.
I know we don't want a mempool requirement, but it sounds like we need some sort of...
No, to compare it to Ethereum, what we'd be really asking for is the EVM spec, which describes the EVM, the stack in the machine, what it can do next, what instruction sets it's allowed to receive. That would be the closest parallel I can think of to Ethereum in the problem we're facing here. It's not how to arrange all the pieces before block making, such as the mempool, and it's not how to verify that the blocks have the correct format from block to block. It's how you're allowed to move the machine or tick the machine forwards during the block making process. Does that answer, sort of draw a parallel that suits, Troy?
Yeah. Well, I think it does. I'm just trying to, because you keep saying intermediate states and whatnot. And for me, the intermediate states are obviously the mempool, but then there's obviously things that drive the mempool, which are the requirements for choosing blocks and whatnot, which is I think where you're getting at.
In our system, the mempool is much less sloppy than the Ethereum one, because the Ethereum mempool has to receive instructions from a multitude of smart contracts, whereas for us it's simpler. You only really receive instructions for one smart contract in one pool, because each contract gets its own pool. Right.
No, that's why I didn't really want to call it a mempool, but that's kind of where it sounded like to me, where it was the direction it's going.
I know what you mean, and that it sounds like that's what I'm asking. That part, I'm not concerned about being able to make us a spec for that.
What you want is the underlying architecture that's driving stuff like the mempool and other things that are ticking boxes to make sure that things are moving forward in block code?
No, it's even finer grained than that. It's
Okay.
what are the rules by which the mempool may be processed to produce the next block?
Well, yeah. Okay. So, that gets back to where I was trying to lead to anyways. Okay. So the mempool in Ethereum is driven by miners. Those miners have contracts which decide how things go based on greed, right? Right. And we want these Boolean decisions being made automatically by some sort of specification that you want. That's like tick box, tick box, tick box, next block, right?
Or next. I'll agree with you because technically that's true, but really it's like tick box, tick box, tick box, intermediate state. Next, tick box, tick box, tick box, next intermediate state. Ultimately, we get to next block.
So how many intermediate states in your head do you think there is for this in reality? Like
I would say it's under 100.
100 intermediate steps.
Under 100 intermediate states that can loop.
Okay.
So one intermediate state is produced per externally received action, basically. No. At least one, but I want finer grain than that because the external actions can trigger an arbitrary number of loopback actions, right, and also an arbitrary number of actions that we wish to send externally outside. Yeah. Right. But you're saying one of the states you wanted to disallow is that the loopback was full. If the governing state machine, I'll just call it if the spec state machine moves from the state of processing the external action back into the state which is get me the next external action to process, and the loopback channel is still full, that is an error. And so I what the hell was that?
So is the loopback channel gathering these calls into a batch file?
The loopback channel is so when you get external actions, the loopback channel allows you to send an action to yourself,
right?
Which is very convenient because otherwise you end up having to use the equivalent of goto in your code,
right?
Because you might want to start back at the top again, and so loopback gives you the power to call yourself, but as it turned out, it doesn't make any sense to allow loopback to not be fully processed by the end of each external action. And so
you were saying full. So is there a buffer that you're saying that you hit a buffer limit where that's it? No more loopback actions can be called at this time until...
Well, I would like to specify that, but I haven't specified it yet, nor have I had the need for it. For loopback actions, it could be in the hundreds of thousands before it became a problem.
Well, I'm speaking from more of a bad actor frame, because these loops, every time you say loops, I think reentries and attacks and
the
denial of service and
those aren't a problem insofar as we rely on the Turing incompleteness of our framework, such that whilst you could arbitrarily hit the loopback, there is a timer on it, so that if you haven't completed your operations within a certain time, you still get billed, but you just get stuck on whatever it errors, and you get stuck with the last state. So sort of don't do that.
All right.
Yeah. I think I'm starting to see clearly, thanks to talking to you guys, I'm starting to see more clearly what I'm asking for. In that it's an independent state chart that is basically just conditions and checks for the intermediate steps that you can go in, which means that I can make modifications to the how this gets done like, it drives me a bit mental whenever I make a fundamental change to the models, and I have to build the whole system up quite slowly, and it's hard to know where it broke. But if I've captured the actual spec in this checker machine, it will be instantly obvious. Like, it will greatly narrow my search space as to what set of function calls in what order from what context caused this error in what I'm expecting.
Right. So this is like a parent level executor state chart.
Yeah, it's
so
like a
when
guardian.
You say
It's like
states,
a guardian.
do you mean anytime you change a state on any sub-state chart in all of it, basically?
No, I mean that
between the blocks, right?
Well, the guardian state chart describes at a abstract level what are the permitted transitions you're allowed to do, and then I write the code that fulfills the requested transitions. Then when that code returns, there's a bunch of checks done, and it will error if they're not done, so that I can immediately focus my attention on the very specific intermediary state during the block formation process that caused the error. Whereas right now, I have no way to check that because I have no spec. I have no spec that is independent of the code making the blocks, I think is the statement I want to make.
Right.
And Troy, you were asking for a requirements doc. It's not there. This would be better than that, I think, because it would be running requirements that you could read it and say, this is canon, like this is the canonical protocol spec as it stands right now, and you could then update a document or automatically generate one anytime you like. But you've got no hope in doing that now. There's no way to do that right now.
Right.
Requirement docs end up being like heavy and out of sync all the time, right? Because like I think it's still in a stage right now where you have to play with things a little bit to get them into the right shape, right?
But that doesn't mean that the requirements doc is extremely valuable, and for having more developers work on this system, it's a necessity. It's just that when I think about how big the doc would be, it would be like writing the spec document for the x86 instruction set. It's gonna be like a ream of paper type of thing.
Right.
Whereas if I can express it in this Guardian state chart, that's way more compact.
Yeah. So this thing wraps all the things that are actually doing the how calculation.
Yeah. And what it will mean is that if I have the Guardian state chart, I can then, there's some tools from the Xstate guys that let you generate all possible paths through that state chart. And so I could then begin to construct tests that exercise the full, every single transition in every order of that protocol state chart can be exercised and checked for. Which is like a thrash test on the underlying code that I can't do right now.
Right.
Furthermore,
there's something sparked in me here. When you're setting up SE Linux, the way you do it is you basically let all the systems that you want to have run, and then you generate a log from that, and then you use that log as a spec. And it prevents anything that gets installed on future versions of like the same operating system from ever being able to run. It kind of sounds like that a little bit.
Right. Yeah. So I guess what I would be asking for now is take what code is here, write a Guardian state chart for it, which then allows the code to be modified with the Guardian's oversight.
Right.
But it also allows the protocol to be specified in a way that is pure requirements and not here's how we did it. Now figure out why we did it.
Right. Yeah, I mean, like, the Guardian thing would be able to tell you pretty clearly the why, I think, if it's built the right way.
Yeah, the Guardian says why that state transition, why those guards, why those conditionals. Okay, and it would make it much easier to display because I want it so that when you want to analyze the engine for your own code, to understand what it's doing to your code and what effects your code is having on the engine, I envisage you being able to see a running version of this Guardian, and that's sort of how you reason about what's going on in the system, so that you don't have to be an expert in the internals to be able to understand the internals and see how your code is running through those internals.
It honestly sounds like a log.
Yeah, it does.
It's like more active than a log a little bit, right?
It's a bit, you're right. It is. It could be. Sorry.
It's a gatekeeping log. It sounds like.
Right, but it's sort of like I could build it as a log to start with, but it would then be sort of lifted off like a vinyl template, and then it's like that is now made independent of the original code that made it.
Right.
Can we call it log 4K? It's just a little better than 4J, right? So
could be log for you. I mean, that's
log for you. There you go. We log for you.
Okay, I think that is what I'm asking for. Now, the next question comes: is that useful for writing a specification document from?
Yes.
Is there a but on the end of that?
No.
No.
No. I mean, diagrams are very helpful and all that stuff for writing requirements documents. A picture speaks 1,000 words. So if you had something that was described as saying like as a flow diagram or however it is,
a state. So it's a state. It'll be a state chart which you could explode out to be a flow diagram if you wanted.
Correct, and then that's fine because you can still go in and put in specific requirements and saying like you have to use this syntax and it'll do this function. That's fine, but then but if you want to see the high level, top level, how everything works and flows together, then diagrams are the best. So I have no problem with that.
Okay.
If you get yourself into an errored state, is this something that you only want for yourself to be able to like make sure that you're building the machine the right way, or is this something
basically it'll be a core dump to go into an errored state, and the Guardian would cause a core dump. Like you've really fucked up. You cannot play in the sandpit anymore. You fucked up.
Cool.
And the only reasonable action to take is halt the entire system.
Halt and catch fire, is that what we're saying?
Yeah, pretty much, because you're like, well, there's no recovery from that. It's not, the Guardian's not designed to help you pick yourself up off the ground, right? It's a menace. The Guardian's meant to be an oppressor, not a helper.
Right. Like, is this part of the runtime is what I'm trying to get
I think
at.
It runs constantly. It's how we keep ourselves as the protocol builders in check, and it's how we would allow anyone else to make a different version of the internals and still be compatible, because we're like, here's the state chart, all you got to do is not break the Guardian, and you can fulfill it any way you please, in any language you please. Just this is the Guardian that you use to stay safe, kids.
So, depending on the level of granularity that you want to run it at, like this thing has to be ridiculously efficient.
Well, I've already done that insofar as when I made Xstate Direct, which is W001 Xstate Direct. It's pure function calls in a sequence that you specify with a state chart. It doesn't get faster than that until you switch languages.
Right. And then the only other kind of open question I have there is, like, there's a back and forth here, right? Like, while you're building the thing, you might not know the state that you want to. I mean, I know you've basically locked down on how you want this engine to work internally, but if you're going to add a feature to it,
right?
And you don't
This is also why I want it, is because to modify a feature, I would modify the Guardian first.
Right.
Because I would describe what I want by a change Guardian. The Guardian would then break every time the particular feature wasn't fulfilled. And then I can sort of stop thinking hard and just focus on getting my code to pass the Guardian, which is way easier than trying to hold the mental model of the Guardian in my head and make the code and run the tests in my head as well.
Yeah, that's a good idea, actually. Like, everything is TDD by default.
By default, yeah. It's top level TDD. It's end-to-end TDD, and it may be extendable to be like multi-actor TDD because you can emulate the Guardian being run on multiple machines, and you may even be able to code some bad actor behaviors in to sort of say, well, if this actor does this, then does the Guardian detect it? Does the Guardian plus the models kick out the bad actor?
It's sitting at this nice level of context where, like, if you think about it as recording everything that's happening, that's one way you could run it.
Yeah.
But if you think about it as, like, proactive, if you think about it as feeding, like, that's the thing you could use to sync a chain or a node up to a correct chain state or something like that, you know? It's basically a wall between where the action comes in and the chain processes it, right?
Yeah.
It would have to be, because it's it's a context above the running of the code.
Yeah. It's a context above.
So, like, I feel like there's, like, we're talking about it as if it's like watching the thing and then making an assertion afterwards.
That's what it's doing. Yeah, it's watching the thing, it's deciding what to do next, and then it's telling it to be done, and then it's checking that it got done right, like a manager.
It also has the correct level of context that you could use it to, like, feed things or set them to the right state.
Such as?
It's just probably a go nowhere type of thought, right? But, like, if you stop thinking of it, or if it had a mode of, like, a proactive mode, not a reactive mode, like, not a stop and check, but more of a, like, let's get the internals into the right state right now kind of thing.
Well, you were talking about how to synchronize a chain.
Mm-hmm.
Oh, I would imagine that there would be a subsection of the Guardian that covered how that was allowed to work too. The synchronization of a chain, because you could describe it in terms of what am I missing, who do I ask for it, how do I build that up? Because it's, I guess, where I fell down the hole with this current implementation was that it's not just a pure, the Guardian actually needs to describe some services that are higher level that require the coordination between multiple machines. And so it's sort of it's a tricky line, because the Guardian's not just spec, it's also a little bit program.
Right. I think you can do it spec though. Like if you're talking about coordinating multiple services, you know that that's always statements about what you're seeing in channels. Like what's in an outbound channel, how long is an inbound channel supposed to take
and
to
what are the
respond to it?
allowed, like, what's the allowed next action in this channel? What's the allowed next state change?
Right.
Okay. How much do you think this system would need to model what's happening on the other validators within itself? Or is it okay to be ignorant of that and only care about sticking to your guardian?
I think it's a design choice. I think it makes sense for this thing to be like, that's a super tough question, man. Because like you could put like the higher level picture into something like this as long as you were committed to running everything through channels.
I guess we could actually, given the transmitted outputs from a foreign validator, you could fast forward your model of their guardian to just the bits that you know for sure happen. You may not know how they got there, but you can talk about the big lumps. Like, you can assume certain things about the state of their guardian. Because the guardian holds state, I guess, is the tricky bit. The guardian holds some context.
I mean, I don't know if it should. That's the thing.
It has to.
Does it?
So are you saying that it holds nonce at some point? Like it's counting?
More than nonce. It's holding... because there's so many loops that can occur within the guardian, like process the first action, the second action, the third action, it needs to hold state, like what action number are we up to? How many actions remain? Right? Like otherwise you can't specify it as a state chart without running out of room on the page unless you use context to allow the finite state machine to do technically infinite things. Right, that's why you have to store state, or else your machine size is unmanageable.
Yeah, because you'd have like infinite permutations, right?
Yeah, but the state chart reduces that down to patterns and uses context as counters to allow the infinite possibilities to be expressed in a finite number of transitions.
Right.
So is that our resource limitation for the Dreamcatcher? Is this you can only do so many state changes in one go, or?
I intend to put a limit on the number of state changes you can do for a single chain in a single block processing cycle, but I'm not totally sold on that. I think that will be an operator-based configuration, just like how in Bitcoin there's like a configuration option for block size. We will pick some numbers that we like, but if you're running your own code, you're welcome to change it. Like, yeah, I don't think what we're talking about here imposes any hard limits. They're more just soft limits that we'll choose based on experience.
Okay.
Well, I think that answers my question finally.
I do have one question. You're talking about modeling external subsystems. Like this is something I've never had clear in my head since we've been talking about validators and validation processes as chains. Right. It's just, is validation like something that is in a chain, or is it about a chain?
Validation can technically run in a chain about a chain which is contained within.
Okay.
So I think the thing that really did our heads in several years ago is the fact that we are making a general purpose execution environment. It necessarily follows that it is capable of executing itself ad infinitum. So, but when you are running the validation process, it is about a chain that you have the full block for. So right. you when you run the process, it doesn't matter whether you're 10 layers deep in like validation within a validation. From your point of view of the executing code, you have full access to the block that you wish to validate. You have 2 blocks, the present one and the next one, and you're repeating the operation of the Guardian to verify that the Guardian was honored in the proposer who put forwards this next block.
Right.
So I guess that Guardian is really the thing that that's what you rerun to validate a block.
Yep, it sounds like the validator to me.
So, okay, well, maybe I'm okay with calling it the validator. It's just the trouble is it collides with a validator as the instance, but
it's overloaded. It's way overloaded.
Yeah.
I think you can call it the validation.
The validation. Validation 4J.
I think we stick with Guardian for now. If there's like
validation. Like these there's a massive word showdown happening soon, I'm sure. Yeah. But I just choose
fight of the century, man.
I just choose words that are at least different and lonely. I don't really care so much what they're called, so long as it's not a tongue twister, and so long as the thing it describes is correct. And I think Guardian's a good thing.
So you don't want me to run around and start calling things like the enumera of the actual block? Is that it?
The enumeration.
No, the enumera. The enumera. To distinguish whether it's a good block versus a bad block, you the enumera of the chain, right?
Yeah, because I guess the Guardian would also contain within it the actions to take when you want to report Byzantine fault detection as well.
Right.
And because what I intend for is that there is a small percentage of Byzantine fault that I want to build into the protocol you must inject periodically. Like, as a properly functioning node, you must behave in a Byzantine way every million blocks or so to check that the other validators correctly picked it up.
That's sneaky. That's good.
Well, it stops people being lazy, right? And just going, yep, the block's fine, block's fine, block's fine. Like, that's what people do. Like, I'm playing fucking that Sega game where you could just bank the Tomcat and make it to level 14 if you just put a Coke can on the controller and just like we can't have that.
I use rubber bands personally.
Well,
right. So, like, modeling the validation process inside of this thing, like, I think you want to stay away from like assuming that you can capture a lot of the other state that's happening on other chains.
Sorry?
Like, anytime you try to put something like this in that tries to model the outside world, it gets very like weird very fast, right?
I don't I think to answer my previous question, I do not believe that we should be trying to model the Guardians within the other computing systems that we peer with. I think there's no point in that. The model with which you make assumptions about the state of your peers is simply the block state. Like, you have the block and you're like, that's all I need to know about this foreign state. Right.
I think that's the right split point for that stuff.
Yeah. Okay. Well, this has been really good. I guess that the Guardian is the validation process. And it sounds good to me that it be separate from the what am I doing as the proposer.
Right. It also is like I don't know, you want to check and make sure, because like it's possibly confusing validation, like validating a state with validation, the validation process of like multiple
that's why
actors acting together.
we're calling it the Guardian state chart to get around that. But it is what a validator, it is doing validation. It is what a validator runs, and it's also what a proposer runs to produce the next block 2, and it's what we base our spec off of. It's what we'll base our formal verification model off. All of that. So that's really good.
No, I've got no issues with calling it Guardian, by the way. It's pretty much fit for purpose naming that.
Okay, I'm glad we finally agree on a word.
Well, if you look through the dictionary, I've only had issues maybe about 5-6%.
There's a probably, most of those words need to change. I'll be the first one to say that. I think the correctness of what they describe is maybe 95%.
Yep, I agree with that.
Sort of, yeah.
An experiment that you could try running is rename everything in the entire system to nonsense words, and then see if the system still makes sense. Have you?
Yeah,
everything is nonsense words already. That's the point.
Like words that don't spark any picture in your head at all, because they're like novel words. Like nobody's ever put that string of letters together before. There's very, very little chance that word would cause some kind of separate image in my mind than your mind. This is why mathematicians use letters for everything, right?
I thought it was because they couldn't be bothered writing.
No, it's because you don't want people to bring their baggage.
Okay.
Well, that was my exact point about certain words in the dictionary to begin with. Baggage.
Yeah.
Either cultural or emotional, you name it. Like this, I was just trying to veer away from possible baggage.
Yeah, no, I think it's a good exercise to do on an ongoing basis for sure.
One day, when there's time, we'll make a tool that makes it trivial to not only rename the dictionary names, but lets us all have different dictionaries, like internationalization, but for individuals.
Well, yeah, that would be good for translating, right?
Yeah.
That might be different.
Because the fact that we're everything's done in English is already an issue, but that's like here nor there yet.
Well, I'd do it in Martian if I could.
Right. So that the Guardian also transcends language or international language as well, because that state chart is immediately can work in Cantonese, right? Whereas a spec document would be bound to English, I believe.
So what does an MVP of that thing look like? Because I think we're probably making assumptions about the possibility that it can be written.
Yeah. I think it looks like a log first, as you guys said. It just logs it'll take a bit of artistry to define what the state transitions are, but I think with a bit of fiddling, that's definitely possible.
How much does it peer into the state of the inner state machine?
Say again, sorry?
How much does it peer into the state of the inner state machine? Like every single log?
That's the art, right? The art is to say when to stop looking any further and be declarative. Like the cut point as to how deep to look into the internal running state is the declarative choice to say this is as far as I want to go. I think that building this thing, I can actually build it a little bit at a time. Like I don't need the whole thing for it to be working. I can just run Guardians over a small, troublesome piece of the state transitions.
So you're saying that Guardians could be modular as well?
Yeah, well, they will be, because they're as a state chart, they'll be nested inside of each other. otherwise, to like that's what gives state charts their compactness, is that nestability. And so I can build just, first of all, independent little state charts for a particular piece, and then gradually wrap them all up higher and higher. And I guess, moreover, it can be like, I mean, the MVP can be just like block to block, right? Like it can be the Guardian's like one lump, and then all we're doing is adding in more spec.
Because I mean, it's starting to sound like not only just a log, but it's also starting to sound like the default library.
The default library.
Yeah.
What do you mean by that?
Well, like it's kind of becoming the like it's the, I guess it would be the fundamental library for the entire Dreamcatcher.
Yep.
Like,
yep, that's right.
Yep.
But in itself, it would have to be coupled with an executor or something. Like the Guardian is, you can write multiple different executors that can pass the Guardian. But yeah, that's the spec of the Dreamcatcher in a state chart.
Yep.
Well, that was simpler than I thought. Sort of also more profound than I thought too. Right, because the Guardian is a state chart, you can then write these covenants that describe individual functions, like the NFA covenant that describes how NFAs work, and that can be slotted into a nested piece of the Guardian, because the Guardian runs around the outside of this even more narrow specification. So you could have like a Guardian format thing for the NFAs too, or for any covenant. Right?
Well, that's what I mean. Like it becomes a default library. Like everything becomes the standard for that particular.
Right. And, I guess if we take to writing covenants as Guardian first, then that sort of could save us getting into the problem that I'm in right now, for one, but it also starts to build out this, or expand on this standard library that Troy's talking about, in a way that we can sort of lay out our roadmap by the areas of the ever-expanding Dreamcatcher state chart that sort of we're going to work on next, and what features it enables.
Yeah.
And then
nothing wrong with that, by the way.
What's that? Sorry.
There's nothing wrong with that way of going.
Yeah, and then we can also like add like color codes on the state chart to show where issues are and problems are, areas that people want to focus on, which I'm actually quite excited about, because having that overall system map would allow new coming developers to rapidly focus in on something and know that they can make a difference just by focusing on that piece, as opposed to a whole lot of spaghetti, and know that if they solve that piece in independence, it will fit into the higher order Guardian, because we have these exhaustive all possibility state tests that run all the time.
I don't know if you can run an all possibility state test all the time on everything.
Yeah,
that's going to be really
well. Okay.
You're always gonna have to pick a subset of the possibilities.
Yeah, so generally speaking, like what the X-State guys do is they pick all possible shortest paths. So they make sure that every state got visited at least once, using the minimum number of paths that you needed to go start to finish to make sure you went everywhere.
Correct.
And then anytime we have errors in the system that weren't caught by that method, we can add like specific paths to make sure we don't get regressions there.
Yeah, I see it. It makes sense to me.
Well, this is fun.
It's like It's almost like a test harness, actually.
It's a big ass test harness, but
it would be the mother of all test harnesses.
Yeah, but it's not just it's not tests that are manually specified. It's auto-generated tests.
Well, it's standardized testing in validation, really. That we set the standard to. Like, hey, this is the minimum standard requirements for reading validation per the Guardian.
Yeah, and then it frees us up to then rapidly translate to something like Rust plus WebAssembly if we want more speed, because we know that we only have to hit the Guardian and we're valid. Right? Otherwise, porting is a bitch. Like an actual...
Is there also, since this would be like library, kind of using the library analogy, would this be a thing where it's like, depending on what you want to do, you'd only use certain Guardian states to describe it? Like you just only pick this Guardian and that Guardian, kind of like a la carte, if you will, in order to make sure you got...
Absolutely. Like if you were talking about you only wanted to work on the NFA covenant, then you'd only pick the Dreamcatcher Guardian plus NFA Guardian. Was that what you meant?
Yeah, it's similar. Like like the AIP type system where you have standardization. Like I wrote the NFA standard, right?
Right.
But that could also be translated to Guardian code, right?
Yeah, that's what. Yep.
Yeah. Okay.
And then you could focus on just that small definition, or you could focus on it in the context of the higher Dreamcatcher Guardian.
Well, I'm just seeing the power of leveraging the fact that if you build on these like building blocks, right, then you got somebody like I wrote this EIP or DCP or whatever we want to call it, and it's like 001, and it's like the default Guardian standard, and then everybody starts citing that standard. So not only do you get the contribution from that and the attribution, but you also get the fact that you get what Ben keeps talking about, where people don't have to keep reusing code.
Well, you're meaning that when people want to make proposals for changes to the Dreamcatcher, they would start by making a change to the Guardian?
Not necessarily. I'm just saying that it could be a separate Guardian module that sits on top of an existing one, as long as that code doesn't like change the fundamental structure of the previous Guardians. It could just be an improvement upon it. Like,
absolutely. So you can release a patch that improves in some way, and so long as it passes Guardian.
Right.
Great. Right. The metrics are better, so use it. Perfect.
Right. Or it runs more efficiently, or
Yeah.
Or we found that no one really uses this
sort of thing.
Or we found that in the wild, no one really used this part of the Guardian anyway, so it deemed it inefficient and or obsolete, so we got rid of it.
Or something like that. Yeah. Well, this was fabulous. Okay, what was the next thing we wanted to?
I actually have to jump off.
Oh, you got to bounce.
Mm-hmm. Can you do one thing? Can you link me to the stuff about testing state charts that you're talking about?
Sure thing. I will do that, and I'll send it to you in Discord.
Yeah, tag me too.
Okay.
It sounds fun.
It's the future. But
yeah.
It's been around a while. It's just that it takes a bit of effort to do. And effort's not popular. But, yeah.
It sure isn't.
But then, I have put in a lot of effort and I'm sick of it. And now I'm like, if I put effort into this model-based testing, things can be less effort now. So the machine is sufficiently complicated to warrant this next level of complexity. Yeah.
It's complicated enough to get more complicated?
It's complicated enough to get not just uncomplicated, but more complicated in the uncomplicatedness of it.
Complicated enough to get complex.
Yeah.
Okay. Well, Troy, do you want to go over the stuff we were going to talk about, or you got to bounce too?
No, I got a few minutes, man. I can
Yeah,
stick
okay.
around.
All right, sweet. Well, I'll stop the stream then. Thank you
See you
very
guys.
much, Ben. I'll see you later.
Okay.
Merry Christmas. Oh, okay.
Oh
Fine.
man, yeah,
Whatever.
and he's gone.